Hi, and welcome to Spectrum Economics and Market Tools. I'm Sarah Oh Lam, a senior fellow at the Technology Policy Institute in Washington, D.C. I'm an attorney and a Ph.D. economist, and I'm happy to share with you, teach this module on spectrum economics and market tools. In this 2.5-week course, the syllabus includes 6 lectures and assignments, including a research paper and student presentations and a final exam. The course examines spectrum economics and market tools such as auctions, secondary markets, unlicensed spectrum, and experimental licenses. Course material will cover the foundations of spectrum valuation methods, allocation, and economic concepts. It's meant to be an undergraduate course, and this should assist in improvement of your analytical skills, particularly with regards to current advances in wireless technology. Over 5 or 6 lectures, we'll be covering an introduction, a look at radio spectrum, policy issues in the news, in headlines. I'll go over Nobel Prize winners in economics related to spectrum research and what we know about spectrum economics. Then we'll go into some material on the history of auctions, spectrum auctions, valuation methods and factors for how economists measure the value of radio spectrum licenses. Then we'll look at market tools. There are different ways that market mechanisms are used to reallocate spectrum licenses, but there are challenges. And so that's why auctions and markets are designed a certain way to overcome those challenges. We will also talk about secondary markets of licenses, incentive auctions, and other tools such as shared regimes, like in the CBRS band and the priority access licenses. Then we'll talk about new developments such as satellite constellations and local governance like private 5G networks. And then I'll conclude by just wrapping up the course material. So like we said before, this course is meant to give you an overview of the different topics that an economist like myself would know about radio spectrum licenses. How the federal regulators think about auctions, allocation, how to determine which bands should be licensed or unlicensed. In this course, you'll have other teachers, probably, or in other courses that go over the legal aspects of spectrum policy, also the engineering. But I'm here to talk about the economics. And so the focus will be on what we know about supply and demand and how to value licenses. This is primarily a lecture course with a student presentation component. Students will also give 5-minute presentations on a current event. Presentations will extend upon headlines. So there are a lot of events in the news that you can talk about in your presentation, and I'll talk a little bit more about what that looks like. They're 5-minute short presentations, and it'll give you experience in doing research and then doing that to present to others. This course also includes a short research paper that will cover one of the spectrum auctions that the Federal Communications Commission has held in the last 20 years. And your research paper should be like a policy brief, like 10 pages, that includes an explanation of one of the auctions using data that you've gathered from the FCC websites and a description of, what was auctioned, which bands, what were any decisions that had to go into the design of the auction, and then how the results came out. So here's a little bit more about your research paper. And there's a handout with a syllabus and the course material, which includes this explanation as well. A 10-page paper describing one U.S. spectrum auction since 1994, is something that this course includes for you. The objective is to understand how the US government holds spectrum auctions. Um, there are several steps involved. There are a lot of lawyers, a lot of people weighing in, and then a lot of economists like myself. And then the auction is held, and then industry members bid for the licenses, and then they're paid out. And often they have build out requirements and like renewal expectations. So basically, from the FCC website, we're asking you to select one auction and to study it and to describe it. So for each spectrum auction, there's a frequency band that is up for bid. Um, in your research paper, please list any technical constraints on usage of the band and the terms of the license. There are often specific band plans and ways that the band is meant to be used. And so please describe those features. And those features are deliberated on by the FCC before the auction. So it'd be helpful if you could describe why those license rules are placed on the band and what the economic motivation is. Is it more valuable if it's designed a certain way? And which industry members are asking for different types of band plans, and why did the FCC decide to run the auction in a particular way? And did it turn out the way that parties expected? Was there as much subscription to the auction as expected? And are there any international comparisons between the US case for this band and other countries? So oftentimes other countries will have a band that they auction similarly to the US. So you can compare, how another country auctioned a certain band. And so I'll be talking about some headlines of auctions recently so you can understand how economists and lawyers and industry representatives keep an eye on auctions and how we talk about them. In addition to the research paper, there's also a presentation that you'll do for each other to describe headlines. So the news headlines, they don't have to be about auctions. They can be about interference conflicts. So this this presentation will be a 5-minute presentation. You'll pick a current event related to radio spectrum, and you'll describe what happened. So, and you'll have PowerPoint slides that show a headline of the story and an explanation of what was happening. You can give background information, what led to this news event, and any information about the frequency band at issue. A lot of times, spectrum bands have a history of different deliberations and negotiations about how the band should be used. So you can look up the history of the band and if there were any prior conflicts or disputes about that particular part of the radio spectrum. And then it'd be helpful if you could describe to your fellow classmates the current state of the situation since that headline has been put out. So you can pick a headline that is like older, that's like from 10 years ago, and then talk about that episode. Or you can pick a headline that's more recent. And you should style your presentations as an objective briefing. Imagine you're talking to a congressman or woman or a regulator, you're a staffer, and you just want to explain what happened, who are the players, what's the resolution, what's the main conflict. So aim for clarity, simplicity, but also depth of understanding. So now I'll start lecture 1, an introduction on spectrum economics and market tools. So in this introduction, I'll talk about spectrum in the news, and I'll also go over Nobel Prize winners that you might have heard of over the years in economics, and why their work is related to spectrum economics. So you can imagine radio spectrum is a very abstract resource. It's a frequency right to use a certain frequency on the electromagnetic spectrum for wireless communications. And there's a lot of economics related to how we think about such an abstract property right. And radio spectrum licenses are intangible assets that are a creation of the regulator. And so these Nobel Prize winners have a lot to say about how we can think about these resources in economic ways. So I'm going to start with that because I think it'll help you think of spectrum economics in terms of the people who are working on it and the news events around it. It makes it a little bit less abstract and more tangible. And then in lectures 2 through 5, I'll just run through this right now. I'll talk about spectrum economics in terms of a history of spectrum auctions by the FCC over the last 20 years. I'll talk about spectrum valuation methods used by accountants and um, companies that have spectrum licenses. So, how they value the particular assets on their balance sheets and in their books, and also the factors that go into how to value a particular license. So, economists are often asked to value a particular spectrum license, but you can imagine that there aren't that many markets for spectrum licenses. So, the price of a particular license depends on prior transactions, similar transactions of similar spectrum bands in the market, but also like features of the particular license. Are there encumbrances? Are there interference protections? How many other neighbors are near the users of this band? So all those factors can go into a prediction or an estimate that economists will use to value a particular band. Um, as in any valuation exercise, there's a range of error, and spectrum in particular are depending on how you think about it, they can be pretty thin markets. They're getting more they're getting thicker with more transactions, like with secondary markets, but there aren't that many spectrum transactions. And so, using the factors and methods, these are um, best estimates for how to value spectrum. So I'll talk about that. Then we'll go into market tools, which will be broken out into 2 lectures, part A and part B. I'll talk about reallocation challenges. So why it's challenging to design reallocation methods. So I'll talk about the history of how the government went from command and control, just deciding who gets what, to a more market-based system for deciding how to sell licenses to the highest bidder. Then I'll talk about secondary markets, so an innovation that has been applied in more recent years, allowing licensees to trade their licenses on a secondary market without having to go through a whole big auction again through the federal government. Secondary markets, this section will also include leasing. So license holders can sublet or sublease their licenses to other users, which provides some liquidity or more flexibility and fluidity in the market for licenses. And then in part B of market tools, I'll talk about incentive auctions. So incentive auctions in the broadcast TV band is the main example of how the government designed a very complex way of reducing the holdout problem, but also incentivizing holders of broadcast TV spectrum to give up their spectrum and to receive compensation to move their analog TV broadcast equipment and into digital TV bands. So I think, the incentive auction episode, or uh, the whole mechanism is worth talking about. And then I'll also talk about other tools like priority tiered sharing regimes, like in the Citizens Band Radio service, and priority access licenses using databases. So we'll talk about that. And then in lecture 5, I'll talk about new developments like things that spectrum regulators have to work out with low Earth orbit satellite constellations like Starlink or OneWeb. These are non-geosynchronous orbit satellites, which are lower in altitude than the geosynchronous satellites that are higher up and that deal with weather and GPS. So these NGSO satellite constellations, the low Earth orbit or LEO constellations, require some decisions by the FCC and the International Trade Union and international standards bodies to figure out what the burdens are on these low Earth orbit satellites to not interfere with each other and to not interfere with geosynchronous satellites and to not interfere with terrestrial wireless users. So we'll talk about that. And then local governance is also a new development to talk about private 5G networks and how that affects how spectrum policy and economics is being considered in that new development. And then in a conclusion lecture, we'll just wrap up all of this material. So first of all, let's go into spectrum in the news. So in 2021, you might have seen on CNBC some headlines like this one here about the C-band auction. So in this headline, it says companies have bid $81 billion for the airwaves to build 5G, and winners will be revealed soon. So the C-band was a big auction that moved incumbent users off of that band, and then because it was known to be valuable for 5G wireless, and the FCC held a big auction where companies put in $81 billion worth of bids. So this gives you an idea of how valuable these airwaves are to wireless carriers. So we'll talk about the C-band a little bit more. Here's another headline about the C-band auction. It becomes the world's costliest mid-band auction yet. So 81 billion was a top figure for a spectrum auction. And in this record-breaking 5G auction, this headline shows that there were 3 main winners and many losers. Verizon was one of the big winners. And again, here's more about the satellite C-band. So in the C-band, we'll talk a little bit about, I'll talk about it in a moment. There were a lot of different players in that band. There were satellite users, and back in 2019, they were discussing how they would be moved out of that band. And here in this Space News article, the chief financial officers of satellite companies and investment bankers were talking about how they could get value out of their spectrum holdings because they were asked to move out of the C-band to allow for an auction. And so these satellite license owners are thinking about how to get the most compensation for their licenses. Investment bankers were also interested because it affects the valuation of the satellite companies that hold the licenses to these bands. And a lot of the discussion about the C-band and the valuation of it depended on how the wireless companies how much they would pay in an auction, like the 81 billion, and how much the satellite companies could hold up the auction or strategically say we want more of that money. So you can imagine that they have a private valuation for what that spectrum means to them, but you know, they're willing to move out of that band and receive compensation if it's more than what they value, what they're using the band for. Or if the amount that they could get out of compensation is way more than the cost of moving their equipment to have similar services in a different band. And so this gives you an idea of just that price differential, and um, how many participants are involved in um, valuing spectrum bands in order to move people around, to move uses around and licensees around. And then there are also other values at play, um, national security and the Defense Department. And so in this headline, you see that the military is also interested in what happens with the new C band if there is aviation risk. And so another concern was if the new 5G users of the band would interfere with current aviation uses that were neighboring the C band. And so there's so many different players and adjacent users and neighbors and incumbents and stakeholders that spectrum reallocation can get very political, but also needs more um, needs interaction from economists to create a market, but also um, politicians and, you know, Defense Department representatives, Congress, the president. There's so many players that weigh in to particular bans with federal and non-federal users. Here's another news headline about yeah, similar. It's also the C band, but this one had a little bit of a different flavor because it involved not the Defense Department, but the Federal Aviation Administration. So the airlines were concerned that the new 5G users on the C band would interfere with their airplane equipment. And so in 2022, there was a big fiasco that involved the air system, the wireless companies, and it did go all the way up to the president. Here's another headline about this particular conflict between federal agencies. In Politico, it says how Washington flew into a 5G mess. The saga of squabbling agencies, warnings of plane crashes, and billions of dollars in spectrum has been years in the making. So, like I said in an earlier headline, the satellite companies were talking about this ban in 2019. But then in 2022, the aviation industry starts raising red flags about this 5G ban. And so you see this headline in Politico. And a lot of Washington was concerned about what was happening in this band. And here, the FAA, which represents interests of airlines, but also the federal government's role in spectrum in this band, the FAA weighs in and says that they want U.S. airlines to replace the radio altimeters that were being interfered with from the 5G users. And so this gives you a good example of how there is disputes about who bears the cost of upgrading their technology. And so is it the 5G, the new 5G networks that want to bring in new technology, or is it the old technologies that are, neighboring, that are using radio equipment that could be retrofitted and replaced to be able to handle 5G transmissions? And so you'll hear different things from the airlines, from the defense industry, from the wireless industry, with claims that who bears the cost to make room for each other. The airline industry will say the radio altimeters are well within their rights um, to to be operating the way they are. They don't need to replace or upgrade their legacy technology because at the time and currently they're within the rules that they're meant to be in. And then the 5G, the new license owners will say it's the airlines that have old technology and um, they're being more sensitive than they should be, or um, they're not filtering out sensitive wireless transmissions that newer technologies could. And so you can imagine that if it were a purely free market, an economist would say, well, the party that wants to move in can just pay the other to replace their technology and upgrade it. How much does it cost? Let's just come to a deal. But there are strategic reasons for holdout, for companies to appeal to politics or to appeal to safety, like excuses or national security risks. And so it gets political very quickly. And the FAA was pulled in, Congress, the White House. And actually, this dispute is not yet resolved. So here you can see in March of this year, 2022, there's still talk about how to upgrade receivers to handle this boundary issue. And even in August, the summer 2022, the parties are still asking for clarity on who's responsible for altimeter upgrades in the planes. And then industry balks at the FAA's 5G risk mitigation plan. They're not happy with that yet. And then now you have also the LEO satellites coming in. Oh, actually, this is a different band. This is 12 gigahertz. So 12 gigahertz is different from C band. But you see similar complaints that, yes, SpaceX says that 5G could disrupt Starlink more than previously thought. In the 12 gigahertz band, there's also 5G wireless going into that band, and there's a boundary where satellite users might be interfered with. And so you see very similar dynamics between the different neighbors saying that interference might be more than we originally thought. The parties say, well, we're within our operating rights when the auction was held and all the studies were done, 5 years ago. But then later on, the parties, when it becomes closer to reality that the new use will be there in the neighboring band, they put up a fight saying that, oh, there's going to be interference. And so the political economy of this, or the process point, is also that, well, the parties had opportunity in the FCC docket 5 years ago to submit their scientific reports before the auction happened. But after these new bidders have put in these billions of dollars to win licenses with these clear rights, then a neighboring use complains that they'll be interfered with, and so there's a lot of talk about reforming process and enabling markets to work better. And for a market to function well, parties need to be able to bid according to their true values, but there are a lot of other considerations here than just the initial bids or price. And so that's why spectrum economics is so interesting and challenging. There are some other analogs. You can think of it like property zoning, how to, in a city, there are all these urban areas that have zoning disputes, and rights of way, and so they're in a situation like that, you have local politicians and you have, other considerations than just, an auction. And so here, we'd like to see more, um, just straight market transactions, but even the shape and form of the auction, how to design it, there are a lot of considerations. And because the spectrum bands and the radio technologies are so multifaceted, they're not all one type of radio transmission. They have different topographies and power levels, and they interact in different shapes and forms. Every auction is a little bit different, and the encumbrances and the band plans look different because the radios on the frequencies, operate differently. They might need paired bands or uplinks and downlinks, or they need more guard bands, or they have just more particular terrestrial to space needs. And so it makes it interesting that every auction, every band has different considerations at play. So next in our introduction, I'm going to talk about Nobel Prize winners who have been awarded prizes in economics related to their work that has impact on what we know about spectrum auctions today. So here are some photos of these economists who have won Nobel Prizes in recent years, and I'll talk about each of them from left to right. We have Paul Milgrom, we have Robert Wilson, Al Roth, Lloyd Shapley, Eleanor Ostrom, and Ronald Coase. So first we have Paul Milgrom and Robert Wilson, who were awarded economics prizes in 2020. They are both Stanford professors at the Stanford Department of Economics. Here's a picture of Robert B. Wilson with his Nobel Prize. And here are the two enjoying a fist bump or elbow bump for their prizes. Paul Milgrom and Robert Wilson are experts in auction theory, and their work in determining how bidders strategically use their auction bids and helped influence the FCC in deciding to run these auctions. They've done work on combinatorial auctions and other sophisticated dynamics. And here's another picture of them. Another set of Nobel Prize winners are Alvin Roth and Lloyd Shapley, also at Stanford. Al Roth is known for work in matching markets. And so if you know about how medical residents are matched to their residency program, medical students are matched to their residency programs every March, his work in matching markets really paved the way towards that system. His work in matching markets also influenced like organ donation markets like kidney and other organ lists. And his work also looks at mechanism design and auction design. And so a lot of the work that he's done has gone into background for spectrum auctions. And Lloyd Shapley as well has done work in market design. Eleanor Ostrom is an economist, or was an economist. She passed away in Indiana, and she won her prize in 2009. Her work was on commons, so property rights that are held in common, and looking at governance and polycentric governance of those commons areas, how local groups can manage their property rights in smaller regions, smaller areas than large. Here's Eleanor. And then we have Ronald Coase, an economics professor at the University of Chicago. He won a Nobel Prize in 1991, and his work was on transaction costs and how other costs can slow down market transactions. So, transaction costs like frictions that make it hard for people to transfer property. And so his work, like Coasean transactions, comes from Coase, says that a trade can happen without frictions, um, would happen without frictions, but because of the frictions, they might not happen. So transaction costs. So a lot of the work in spectrum markets, a lot of the political difficulties and other frictions in trading spectrum are what Coase was talking about, transaction costs.